Hello, everyone, and welcome to our presentation of the progress of our project, which is the Optical Mark Recognition Exam Grader. My name is Demian Velasco Gomez Llanos, and I am with Santiago Arreola Munguia and Marco Antonio Manjarres Fernandez, and we will show you right now the progress that we have in our current project. So basically what it does up until today, this project loads an exam image and normalizes it. It resizes in and puts it in a grayscale, then blurs it and obtains the edges, then finds the main contours and keeps them in a rectangular candidates into rectangular candidates. It orders those corners and applies perspective warp for the flat sheet view, which is basically where the options of the exam are, and it shows a stock debug image view of key stages for quick QA, basically to check the progress of the project up until today.
Before we can analyze the exam sheet, we need to pre-process the image. The first step is to resize it to a fixed working size, in this case 700 by 700. This ensures consistency across all sheets, which is critical because the detection algorithm expects a standardized input. Next, we convert the image to grayscale to simplify the information and reduce computational cost. Then we apply a Gaussian blur. This helps to smooth out noise like small printing imperfections or shadows from the scanner, so that the edges become clearer. Finally, we use the canny edge detector. This technique emphasizes the boundaries of shapes in the image, which prepare us for the contour detection stage. The idea is to establish the outline of the exam sheet and the answer bubbles so they can be identified reliably in the next step. Once the image has been pre-processed, we can move on to the contour detection. We extract the external contours, which are essentially the outlines of the shapes in the image. For debugging processes, we overlay them in green so it is easier to see what the algorithm is detecting. After that, we applied filtering. We only keep contours that have an area larger than 50 pixels and that can be approximately to 4 points, meaning they are like to be rectangular. This helps eliminate noise and irrelevant shapes. Finally, we sort the contours by area, which allows us to pick out our largest rectangle, the main exam sheet itself, as well as the smaller rectangular regions reserved for the grade box. With this step, we've isolated the regions of interest and we are ready to move on to the extracting and grading the answer bubbles.
For the final step in our working prototype, we have the cornering and the perspective warp. How these work is first, we extract the corners on the top rectangles, which include the sheet plus the grade box. Here we can see the example. We are getting the corners of each square and labeling them either green or blue, depending on which of the two squares they are. Then we can reorder to a consistent order, displayed here, TL, TR, BL, BR, top left, top right, bottom left, bottom right. And then we can use this order to perspective warp into a flat square that we will use to analyze the view. This is put into a different size depending on which of the squares it is. If it is the actual sheet, then it is resized to 700 times 700. And if it's the grade box, it's resized to a 325 times 150. This to differentiate which of the two boxes we are working with. Now, what we haven't implemented yet into our prototype is the bubble grid parsing, which is, well, how we will detect what choice was filled in the sheet, and B, the answer key ingestion and the scoring. Obviously, since we haven't been able to detect which bubbles have been selected, we also can't grade the test and find out if the answer selected is the correct one or if it isn't. These are the two steps that we are missing for reaching the completion of the project. And that would be all for our prototype. Thank you for your attention.